Hello to you, Jeff.
Good morning or good afternoon, James. Thanks for having me.
I think it is officially afternoon, this as far as I can tell at this point.
I know, I lose track of time.
Now, your job title has a lot of syllables in it. You're General Electric Digital's Vice President of Intelligent Systems. I had to practice that. Still don't think I got it right.
Yeah, no sweat. Well, let's talk about it. And what do we mean by that?
Yeah.
My background, I've spent the last 10 years or so building and running two different advanced analytics and machine learning companies. One was based around a very popular open source language called R, where we had the great opportunity to sell into a lot of who you would think of as being the who's who of data-driven companies like Facebook and American Express and Goldman Sachs. And spend a lot of time understanding how these early adopters were thinking about embedding advanced analytics and data within their business processes and products. After that one was acquired to Microsoft, we really wanted to think about, I wanted to understand how you solve this problem, the big challenge of taking these techniques, putting them from whiteboard into production, while at the same time marrying that or merging it with the resurgence in this interest in this field called machine learning. And so Wise.io was dedicated to that, where we basically were focused on building production machine learning capability around specific applications.
And you were the CEO of Wise.io, which is then GE acquired Wise.io.
Exactly.
And then it moved out into a unit called Assist.io. Am I right in the history there?
That's correct. It was called Smart Assist, and they actually renamed it into a company called AnswerIQ, which is providing intelligent customer support solutions to big brands like Groupon and Pinterest and people like that. So to come back to your question, why is my title now Intelligent Systems?
Right. And as a very short tangent, did GE have someone who was the VP of Intelligent Systems before you? Or are you the first person to have that? Okay, so you're the first person to have that title.
I am.
That's a lot of pressure, actually.
I guess.
Don't mess it up.
No pressure because the bar is very low. But there is a story and there is a reason behind that. So one of our core beliefs, and we can come back and talk a little bit about what we mean by machine learning, how it's being used. But one of the things that we learned at Wise was that there's a very big difference between using machine learning for exploratory purposes or attempting to apply a machine learning algorithm to a problem versus using machine learning in production for large-scale systems that are continuously improving over time. And the latter is it's a very challenging problem that very few companies in the world have mastered. And so we started using the word intelligent systems to refer to machine learning running in production for mission critical workflows. That's the reason for that.
Right. So I want to talk about how machine learning gets used in the real world, but I'd like to actually stop and do sort of a little elementary 101 thing and have you literally define machine learning. You kind of just did. I want to make it really clear. My brain is a little slow.
Sure.
When I think about machine learning, I think about a software system that evolves and changes in response to data over time.
Yep.
Is that correct, or how would you literally define machine learning?
It is. So the most basic literal definition of machine learning, it's a very broad field, which can be considered a subset of the broader field of artificial intelligence. But machine learning specifically refers to the ability for computers to learn without being explicitly programmed. And so there's different subsets of machine learning. There's what's called supervised learning and unsupervised learning. And what those mean in general, supervised learning is in particular the field that we focus on. It doesn't mean that it's supervised by humans, but rather what it means is that it's learning from past examples. So if you think of the world of analytics or predictive analytics or statistics, as it used to be called, what that relies upon is it relies upon an expert human being to formulate and test a hypothesis. So for example, in the consumer world, you might have the hypothesis that a lower price leads to more sales. And what you would do is you would have this expert human being formulate that idea and then test the relationship between price and the amount that was sold. What machine learning does, and supervised machine learning in particular, is it flips that paradigm on its head. And what it does is it looks at the historical results and it looks at what were my past sales and it infers the relationships of the variables that drove those sales. And so it basically takes that process and it reverse engineers the process of statistical modeling. Where it becomes really interesting is that now you've removed that human bottleneck in formulating those hypotheses. So machine learning becomes very useful and very important in large data and large variable environments where that complexity overwhelms the ability for humans to interpret all of that data and all of that signal.
Right. And I guess in some hypothetical future world, the machine learning system would not just evolve, but would literally begin to teach itself. And we get into our artificial intelligence and the singularity and all that, which is another topic we don't need to.
Another topic, but certainly been some interesting stuff there around DeepMind and Google's work around Go and AlphaGo and some of the self-programming there. And in particular, that's another field, leveraging something called reinforcement learning.
Mm-hmm. Let's talk about some real world examples of machine learning. I know that, correct me if I'm wrong, GE works with Twilio, MailChimp, Zendesk, Zenefits. What are a couple examples of how they're really using machine learning in the real world?
Yeah, sure, absolutely. So those examples were customers of ours or customers of Wise when we were an independent entity. And what we were doing was we were providing intelligence-driven customer support solutions. So if you look at those companies that you just mentioned, what do they do and what do they use? They use a customer support platform like Salesforce or like Zendesk. And in the case of somebody like a Groupon, they get millions of customer inquiries every month. And they have several thousand customer support agents around the world who are responsible for opening those inquiries, reading them, understanding them, and then deciding, who do I send this to? How do I reply to the customer? And how do I resolve that? And so what we had built is we built the machine learning platform capability to embed within those support applications to both augment and automate the decision-making of those customer support agents. And so what we then did is, as you mentioned previously, we spun that product and solution off. We've now taken that same paradigm for intelligent decision-making within existing workflows, and we're applying that broadly across the GE industrial businesses.
Mm-hmm. Isn't one of the problems or one of the challenges in this is that, as the system evolves, that a human has to evaluate how good a job it's doing. So if the system is going to begin to replace those humans that are opening the emails or the queries, doesn't it at some level a human has to evaluate how that is going?
Yeah, absolutely. And there is tremendous both art and science to that. And one of the areas that we're spending a lot of time now is thinking about the concept of user experience design in the context of these intelligent systems. Because that feedback loop that you described is so critical to having these learning systems actually learn and improve. Right. But if you require the humans to provide explicit feedback in order to make that happen, it's unlikely to be successful, and the humans are unlikely to do that. So we believe that
it's too slow.
I'm sorry?
Because it's too slow, or what is it? Does it make it unsuccessful because it's too slow, or what makes it unsuccessful?
What makes it unsuccessful is the fact that if you take somebody out of their typical workflow and ask them to explicitly provide feedback, they're unlikely to do so. And so we believe that you get more feedback and better feedback if you naturally integrate this into the products and solutions that people are already using.
Mm-hmm. So say there's a company out there and they've heard about machine learning, they understand it, they want to get on board. What would you say to them? Like, how do they use it? How do they leverage it? Like, how do they actually get their hands on it?
Yeah. So I give really the same 2 or 3 recommendations for how to get started. And first of all, there was a great article that came out and was written in, I think, HBR, Harvard Business Review, a couple months ago. And the title of the article was, if your company is not good at analytics, you're not going to be good at artificial intelligence. And the spirit of that was, everybody wants to think that machine learning or AI is a silver bullet that's going to solve these very hard problems, these big data problems, but it's really not. And so the steps to get there are, first, machine learning works well on large scales of data that have been aggregated together. That doesn't necessarily be structured data, but there needs to be a good structure to the way that data is stored and aggregated. Number two is if you look at the value chain of how one of these production machine learning systems comes into existence, there's four things that are needed. There is computational power, there is algorithms, there's this unique data that we referred to, and finally there's domain expertise. And so the second thing that's needed is a deep understanding of what that data means in the context of relevant business decisions. The third thing then that is necessary is an idea of what the good outcomes and the workflows are around that data relative to the domain that is being solved for. And if you can start with those three things and start to help have people make and record and document basic decisions on top of that data, it's then possible to layer on top machine learning that can start to take over and mimic the human decision making that occurs on top of that.
But I'm guessing even with that expertise, for many companies, they're going to look out of house for assistance with that. I mean, is it realistic to think they can go through a large cloud provider and use one of their machine learning tools? I think
so let's come back to that value chain that we just talked about of computational power, algorithms, data, and domain expertise. So the answer is for those first two, absolutely. You can look to Amazon or Microsoft or Google for the computational power and the algorithms. However, one of the things that we've learned and the industry has really started to learn is that those parts of the value chain are starting to be commoditized. And they are a necessary but insufficient component of delivering a value-creating solution. So yes, the recommendation would be to companies to think about leveraging what is available as much as possible. But if you assume that that is the case, you still need to be able to have access to your own unique data and domain expertise, knowing how to apply those tools. And the latter is non-trivial and very challenging. The upshot, where I think the industry is really going, is there's a tremendous opportunity for companies to be very thoughtful about their build-buy decisions and how they're consuming machine learning-driven solutions. And in particular, my personal belief is that we're going to see more and more companies be thoughtful about only building at those areas which are a unique core competence to their business, and more consuming machine learning powered solutions at the periphery where they don't have a competitive advantage.
Interesting. Okay. Well, I mean, to put it in context, is it correct to say that the machine learning sector is still so nascent that it's as much of a dream and a hope as it is mostly a reality in business today?
Yeah, I would answer it this way, which is we are extremely early, just like we're extremely early in extracting real value out of the big data wave that was occurring 5 years ago. Where we are is I believe that what we're starting to see is a maturing of the tools. What we're seeing at the same time is the very early edge of solutions that are leveraging those tools. And what I think we are going to see more and more of over the coming years, both on the consumer side as well as on the industrial side, is solutions or products that are delivering outcomes to the customers on data that has been aggregated across a large customer base and is then turbocharged by machine learning or AI. And we've started to see examples of that in things like the way Uber drives network effects in things like Uber Pool, what Google does with Google Maps, for example, and taking how they think about their business model and their data-driven business model powered by machine learning and applying that to many, many other sectors, I think we're going to see become very powerful.
How is, for example, in the Uber Pool example, how is machine learning driving that?
Yeah, absolutely. So you could take the example of by understanding and recognizing the history of all of the trips that an individual user has made where they were when they called. So I'll take an example. I live in the Mission District of San Francisco, and I work in the financial district. The ability to look at and understand that 3 days a week, I'm likely at 8 in the morning to call an Uber to go from the Mission into the financial district is pretty interesting. But the ability to not just look at me as an individual, but all of those users within San Francisco, and now be able to ask probabilistic questions to say, oh, it's likely that I'm likely to go from A to B. Somebody else is likely to be nearby. What they're able to do is provide me with a shorter trip for less money, which entices me to take more trips, which gives them more data about where I am likely to be. And as more and more of that happens, they can then apply these machine learning driven algorithms on top to optimize those trips and those outcomes.
And the interesting thing about that is that could not be done with humans alone. You need an intelligent software system to do that. Unless you had 10,000 people on staff that could just sit there and do that, but it would not be practical. So in essence, it points to the fact that machine learning provides an exceptionally critical competitive advantage.
That's right.
That is going to make a big difference.
It's exactly right. And what to me is so fascinating now, having been a part of GE for almost exactly 1 year, we just celebrated our 1 year anniversary, is that we can start to see and apply those same patterns around data-driven business models. And so one of the things that's been very interesting to me is, as we were thinking about coming on board, people always said, well, it's going to be really challenging because GE isn't a software company. Certainly trying to become a software company. But what was really fascinating to me is, as really understood what this company was about and where we make tremendous amounts of money, is in our services businesses. So if you take our aviation business unit, for example, we sell tremendous amount of jet engines, and we make a reasonable amount of money on those jet engines, but we make a tremendous amount of money helping to manage and service those over their next 20 or 30 years of their lifetime. And the way that we did that was very much in the same way that Google or Uber are providing data-driven outcomes as a service. We were just doing it on an older software stack that now, as we start to think about things like Predix, our Internet of Things platform, things like our intelligent systems platform, we can help to modernize and turbocharge those businesses that have been so successful and so profitable for this company.
Mm-hmm. Well, then let's look to the future. If we're having this conversation 2-3 years out, and we're talking about machine learning, where is it going, and how can a business prepare for where it's going to be, say, 24, 36 months from now?
Yeah, absolutely. So the first thing I would say is it's really going to be inevitable that these technologies will start to become more pervasive, and they will start to become more embedded in all of the products and services that you consume. How to become prepared for it is much like we were discussing a few years ago, which is first and foremost is to understand the business processes within your organization and the data that drives them. Because it's not possible to apply these techniques to them without understanding how people are making decisions, what the outcomes are, and what data drives that. Mm-hmm. So the combination of those two, people doing more and more of that, as well as starting to see these become easier to use, easier to consume, I expect it to be pervasive across business processing, across industries in the sort of 3 to 5 year type of time frame.
Mm-hmm. It seems like it's going to be a necessary competitive tool. Look, if you're not wielding it, if you don't have it, you're going to fall behind. So it's like it's not going to be optional in one of these years in the future.
I think that's absolutely right. I would describe it, though, as necessary but insufficient. And one of the things that I always recommend when I'm talking to peers or even friends at other companies is that the tools are important. But what actually, frankly, interests me more these days is thinking about the business model around these tools. Because it's not just that having machine learning algorithms or capability is good, but rather it's just like we were talking about with Uber, just like we were talking about with Google, for example, around spam detection in Gmail. These systems work better the more data they have to be applied against. And if you can figure out a business model that entices people to provide you with more data in return for better results, that is a very powerful competitive advantage that companies can take advantage of.
Sounds good. Jeff, thank you very much for your expertise today. I'll send you the link when we're done. We can all tweet about it. Thanks a lot.
Absolutely. Well, great talking to you. Thanks for having me.